This is another exciting edition of the World Construction Magazine, powered by olawandecompany.com.ng. Today we are dealing with geotechnical engineering. Geotechnical engineering is the branch of engineering concerned with the analysis, design, and construction of foundations, slope, retaining structures, embankment, tunnels, levee, walls, landfills, and other systems that are made of or are supported by soil or rock. The geotechnical research ranges in nature from analytical and numerical study of geotechnical problems to constructive modeling, experimental modeling, and designing. Geotechnical plays a key role in all civil engineering projects built on or in the ground, and it is vital for the assessment of natural hazards such as earthquakes, liquefactions, sinkholes, rockfalls, and landslides. Geoprofession refers to the engineering disciplines that relate to the earth and environmental services applied to it. 4 engineering branches that relate to geotechnical engineering include 1. Environmental engineering. This is probably the closest in relation to the geotechnical engineering. Environmental engineers try to solve problems facing the environment by using the principles of engineering, chemistry, and biology. The task of environmental engineers include 1. Preparing and evaluating investigation reports, designing water reclamation, air pollution control, and waste conversion projects, providing technical support for projects, obtaining and updating plans and procedures, and advising corporation and government about the same, making sure municipal and industrial facilities comply with environmental regulations. 4. Analyzing scientific data and performing quality control checks, monitoring the progress of environmental improvement programs. 7. Conducting studies about hazardous waste management. 8. Environmental engineers also assess whether the sites are safe enough for construction, whereas geotechnical engineers want to make sure that no humans are endangered during construction or after construction or after the effect of construction. Environmental engineers make sure the wildlife and nature aren't harmed as well. 2. Geological engineering. Geological engineering is also known as engineering geology. Geology, as we all know, is the study of pressure and time, more specifically, the effect that these two elements have on rocks. Engineering geologists are concerned with the apply of the geological sciences to engineering study in order to assure that the company has accounted for the geological factors of the engineering work, such as design, location, operation, construction, and maintenance. Engineering geologists are educated about the recognition and interpretation of natural processes. They understand how these processes impact human-made structures and vice versa. They also mitigate against hazards resulting from adverse natural or human-made conditions. Their prime objective is to protect life and property against damage caused by various geological conditions such as cyclones, earthquakes, and floods. Number 2, water resource engineering. Another field that can offer assistance is water resource engineering, also known as hydrogeology. Like environmental engineering, water resource engineering is a subset of civil engineering. Water resource engineers design and develop systems and equipment for water resource management, facilities, and water treatment plants. With this equipment, they can help manage human resources. They also oversee the construction and maintenance of these systems, water treatment plants, sewage systems, underground wells, and natural flowing springs are some of the areas where water resource engineers operate. They are in charge of treating the water and managing aquatic resources. This is why they build tools and equipment to help with their costs. They analyze data from other places in the area to develop the best procedures. This is a huge task, we know, as they must keep the water clean and free of contaminants. Obviously, clean water is a necessity wherever we live. The water resource engineers must also take government regulations and their budget into account when designing these systems. They may work for the government themselves or at separate engineering firms. They collaborate with geotechnical engineers and advise them on constructing, and that it does not affect the water. The water resource managers must also bring fresh clean water to newly built area. Fourth, and the last one, we have climate engineering. As their name suggests, climate engineering is engineering with respect to the Earth's climate. Climate engineers attempt to intervene with the Earth's climate in a bid to prevent it from changing too adversely. The main aim is to reduce global warming. They can do this by either removing carbon dioxide or managing solar radiation. Carbon dioxide is a greenhouse gas and contributes to the heating up of the earth because it prevents heat from escaping. By eliminating some of it from the atmosphere, the engineers hope to decrease climate change. Solar radiation management is when climate engineers design and develop tools so the earth will absorb less solar radiation. It goes directly to the root of the problem and tries to fix it. They are not the simple solution to climate change and must not be used as the sole method to fix the overall temperature of the earth. In fact, we should all do our part if we want the earth to remain a habitable place for the future generations. There are the fields that relate to geotechnical engineering and what Olawande company is doing with the World Construction magazine. This company use their expertise to help us design and construct buildings, roads, and bridges in an eco-friendly manner. Why not contact Olawande Company through olawandecompany.com.ng for your next project globally? This is World Construction Magazine, powered by olawandecompany.com.ng.